Hi, good morning or good afternoon or good evening, depending on where you are at the moment, like every day. Welcome to day 3 of the Docker training. And today, oops, excuse me, let me just switch these windows around. So today we're going to write some compose files, well, at least one compose file for the Wordsmith application. And then we are going to go back to Docker files. We are going to see how to write better Docker files, how to optimize our images, how to achieve smaller images, faster builds. We are also going to talk about how to troubleshoot containers. So when something goes wrong, when there is a problem in a container, what kind of tools do we have to find out what's going on? All right, and so we're going to start with compose files. So, previously in Docker training, we've wrote Docker files for the Wordsmith application. We had a web frontend in Go, we had an API backend in Java, we had a Postgres database. We wrote Docker files for these 3 components, but we started the components, but we did not connect them together yet. So, as an example, it was not a very visual, not a very concrete example. So that's what we're going to do today. We're going to connect these containers together and hopefully see that demo app in full. So I'm connected to my Docker machine here. I'll go to the Wordsmith directory and at this point, so we have the different components of the application, DB, web, words. We have our Docker file, and what we need is the compose file. So how do we write this? Well, we create a docker compose.yaml. We need to put a version tag here, and that's always going to be version 3. So I I had a question about because yesterday I was a little bit vague about, oh, you can put version 2 or version 3, it's fine, and I did not really expand on that. So you might wonder, wait, should I put version 3 or version 2? Like, what's the difference? So this is it's almost the same. So what happened is that at first we had Compose version 1, and in Compose version 1, you didn't even need to put the version number. You would put directly the containers. So you would put something like web build blah blah blah, words maybe like build blah blah blah, and db build whatever. That was Compose version 1. And then Docker added support for networks and volumes and things like that. So the maintainers of Compose had to think about, how are we going to manage that? And the solution was to say, well, we're going to have a services section here, and we're going to put all that in the services section. And optionally, you can also add some volumes here, and also let's sure this is a comment so that it doesn't break everything. You can also have some networks here, and I'm not even going to show you how we do volumes and networks on Compose because I don't think that's very useful. I will explain after why, etc. But so for now, we don't worry about volumes and networks on Compose. But to make the difference between the old style format and the new one, they decided, hey, let's put version, and it should be at first version 2. So then later, Swarm came around. So Swarm is an orchestration system for Docker. And with Swarm, you can have a cluster of Docker machines, and you can have scaling. You can have like some particular things related to that. And so what the maintainers of Compose did is that they added these new Swarm specific options and decided that it would be version 3. But if you're not using this special Swarm features, then there is no difference between version 2 and version 3. So that's why I often say like this, oh yeah, you could put version 2, version 3, it's kind of the same thing. And sometimes folks ask me, wait a minute, I mean, if there are two different versions, there has to be a good reason, right? And yes, there is a good reason, but if you're not using Swarm in practice, the differences won't be noticeable. Then after a while, we ended up in that situation, which was not great, where you had some features that had been added to version 2, some features added to version 3, some tiny little differences. There were some little differences in the way that Compose manages environment variables. So eventually all that was leveled, like homogenized, made similar. So now to this day, you know, like for most applications, version 2 or version 3 doesn't matter. For a while, I was recommending folks to use version 2 because if somebody was using an older version of Compose, at least it would be more compatible. But today, everybody is using more recent versions of Compose, so we could put version 3 and we would be sure that this would work everywhere. Okay, so here we are, version 3, services, web, words, DB. What do we need to add to each service? Well, in each service, in Compose, one service translates to one container. And so for each service, we need to add either build or image. Build if we want to build with a Docker file, and image if we want to use a pre-built image from the Docker Hub or from some other registry. So here I want to use build, and I need to indicate the directory where the Docker file is located. Personally, I like to be a very boring and predictable person. So if I have services called web, words, and DB, I like to put them in directory web, words, and DB so that everything can be very predictable. You know, web, build, web, words, build, words, DB, build, DB. I don't know. I feel like it's it's easier to read, to understand. It's easier to catch if there is a mistake, etc., etc. All right. Do we need anything else? Yes, we need to expose the web UI. I mean, if we do that, the application will start. I mean, it will build, it will start, and all the containers will be connected together. But we won't be able to connect to the application, so that will be a little bit boring. So let's see if I go to the explanations here in English. Exercise number 2, compose file. Note the web service should be exposed. Okay, and what port should be exposed? Well, if we look again at the instructions, it says for web, it says that it listens on port 80. Okay, so we're going to add ports. And here you put a list of ports. So I'm going to say port 8888 maps to port 80. All right, well, let's try this and see what happens. So I do docker compose up. So this is going to build the 3 container images. And I also kind of like the new builder because you can see like the duration of each step, and that already gives you an idea of so I can see that this one, the one that is longer than the others, it's Wordsmith words, so that's the Java one, and it's because of the Java installation. So I could start thinking, if I want to make that build faster, that's probably where I want to do some optimizations. right. Almost there. And by the way, after we get the app up and running, we're going to see what it takes to have that app running multiple times, side by side, and we will that will give us opportunities or excuse, if you will, to learn interesting features of Compose, how to manipulate the environment, set default values, etc., etc. Because for those of you who tried that exercise, you probably found that I hope you found it was relatively easy, because all you need is literally that little Compose file I was showing you, which is what, less than 10 lines. So we're going to see more advanced features after that. All right. This is really long, but we're going to get there eventually. Shouldn't be that long. So this is downloading packages from the Ubuntu mirrors, and it's getting them from archive.ubuntu.com, and I suspect that maybe this is like something based on geolocation, and maybe it's picking the wrong mirror or something like that, because it shouldn't be that long, but it is still progressing. So I'm going to give it an extra minute to complete. Yeah, I wonder if there might be something wrong with the either with the Ubuntu mirrors, or again, it could be a geolocation issue. Like, for instance, if I select this and I try, let's see, I could do an HTTP ping here. Yeah, that doesn't seem right. Very interesting. So out of curiosity, if I try the same thing but locally, HTTP ping. No, I don't have HTTP ping. That's unfortunate. No, sorry. That seems to work. How could I HTTP ping from here? Yeah, maybe I was trying to do an HTTP ping, but maybe I could start with just a normal ping. That would be a good starting point. So that ping is okay. Okay, it eventually completed, but I'm kind of, yeah, ping seems to be okay, but and now HTTP ping is kind of all right, even though 200 milliseconds, that's pretty slow. Well, corresponds to a couple of front trips because of the TCP three-way handshake. Okay, anyway, it would be pretty interesting to troubleshoot why the Ubuntu mirror is being slow, but I think it might be a little bit off topic, so I'm going to leave that aside for now. But if this is something that happens to you in your build pipeline, because that's actually I wouldn't say a common problem, because Thankfully, it doesn't happen all the time, but you might very well be in situations where when your build pipeline is being slow because of downloads on something else, Ubuntu mirrors or Red Hat mirrors or NPM, etc., etc. And in that particular situation, since I see that it's getting something from archive.ubuntu.com, I would check, is this picking the right mirror? Because I suppose, but I didn't check that, so we would have to be sure. I suppose that archive.ubuntu.com is using some kind of CDN or some geographical system, so that if I'm on a machine in the US, archive.ubuntu.com is going to be a US server, and if I'm in Europe, it's going to be an European server, and so on and so on. But sometimes these things don't go super well, and so it would be worth investigating, hey, do I have a way to directly pick a server that is closer to my location? Like in that case, the VMs are in US Central, so I could say, hey, is there a way to, instead of archive.ubuntu.com, can I have something like us.ubuntu.com or whatever? And conversely, if I'm, let's say, in Japan, using a US server would probably be fairly slow, and I would have to try to find a closer mirror. Anyway, at that point, hopefully we have the app up and running, and we can connect to it on port 8888. So I'm going to, go there, 8888, and that doesn't work. All right, let's try and find out what's happening. Stop that. See how Wordsmith Web is taking a little bit of time to stop, and this is the signal problem that we had yesterday. So I'm going to fix that. I'm going to edit web Docker file, and I'm going to switch back to the JSON syntax here so that my app stops faster. Okay, second problem, why? Oh, okay, that doesn't work because I was a little bit distracted and I exposed port 80 of DB instead of web, indeed. So let's fix that. Let's put that here. And let's do Docker Compose up. So this time, as you can see, it doesn't need to build again, so everything starts right away. And if I go here and reload, yep, it works. And so we can see, I don't know what's the name of that particular game when you pick random name and put random names and put them together to make a funny sentence. So we see a broken microservice helps a broken microservice. So it works, but a Madlib, yes, thanks. It works, but it would be nicer if we had different nouns and different adjectives. So how can we improve that? In that particular scenario, the way that this program works is that each backend is going to pick a random noun and verb and adjective and then return always the same. So if I want to have more interesting sentences, I need to have multiple API backends and load balancing. How do we do that? Well, there is a possibility with Compose. So first, going back to the signal issue, you can see that this is still taking 10 seconds to stop. Even though I thought I had fixed it, like I put CMD with the brackets and JSON syntax, I'm like, what's going on? Well, what's going on is that when you do Docker Compose up, it only builds if it needs to, which means that when I did Docker Compose up here, it did not rebuild. It did not take in account the changes I've made to the Docker file. In my opinion, this is not very good user experience. In my opinion, Docker Compose Up should do the build every time, but it's a kind of a legacy decision. The first versions of Compose only built images when the images did not exist, and so then we're kind of stuck with that decision now. So, oh, by the way, when it's doing this and you want to stop immediately, you can do Control-C, and then it's going to kill the container. So if you're very impatient and you don't want to wait the 10 seconds, just hit Control-C again and you're good. Okay, now, when I do Docker Compose Up, if I want to be sure that there's going to be a build, I can use --build. So now it's going to redo the build, but as you can see, the build was very fast thanks to caching. And so that's why, in my very personal opinion, Docker Compose Up --build should be the default. All right, so I still have my app that works. That's great. Now, if I do Control-C, everything stops right away. Awesome. And so now if I want to have some scaling, I add --scale words equal, I don't know, 7. And now you can see that it's creating words 1, 2, 3, 4, 5, 6, 7. And now if I reload this page, we get like the impressive Viking smashes the famous fjord. And each time I reload, I get a different sentence. All right, so we got that up and running. Yay, awesome. So I see that we have a couple of questions. First question, yes, very good question about do Docker containers get some information from the host, like location, locale, etc., or are they completely isolated? A little bit of both, and I'm pretty sure that's what AJ indicated. Yeah, there is some information kind of leaking from the host to the container. I'm just going to give you a couple of examples. I'm going to do here docker run-ti alpine, and I'm going to also do it here on my local machine, docker run-ti alpine. And let's do some comparisons. So for instance, if I look at the amount of available memory, I can see the memory of the host. Here I see I have 4 gigs of memory. Here I have 32 gigs of memory. I see that I have some swap. If I use nproc, that tells me the number of CPUs. So I can see we have 2 CPUs here, 20 CPUs there. So of course we can see some information. Now let's say I install curl, and then I use curl. It's icanhasip.com. Yep, there we go. So icanhasip, that's a little web service that that tells you your local IP address, or at least not exactly your local IP address, but the IP address you have seen from the outside world. So of course, this lets me know what's the IP address. So in that case, that's the IP address of the Docker VM. In that case, that's the IP address of my internet connection here. So again, lots of information that kind of leaks in the container. I can also do uname-aid, which is going to tell me like the kernel version, the architecture. So again, lots of information here. However, if I try to go a little bit farther, like I'm like, what kind of distro is running outside of the container? Well, I get a hint actually in the kernel version, because that one says 203 Ubuntu. So I guess, oh, this is probably running on Ubuntu. I say probably because yes, there is 99% chance that the machine is running Ubuntu, but there is also 1% chance that I'm dealing with a very facetious, a very playful sysadmin who would be running an Ubuntu kernel on a completely different machine to make me think that we are on Ubuntu. Same thing here, I see Arch, so that's for Arch Linux, and indeed, my machine here is running Arch Linux, but again, it could be a joke from the local sysadmin using an Arch Linux kernel on a completely different thing to make me believe that the container is on Arch Linux, even though it's not. Beyond that, we don't get a lot of information on the host. Environment variables, nope. Well, location. So location, we kind of get the location if we use services like this. You know, like if we, let's see, do I have Whois here? Yes, okay. So who is that? That might tell us that we are on, nope, it's not like that. Okay, so maybe I need to use a better Whois query here. Yes, okay. Give me just 1 second to run that demo. So once I have my IP address like this, I can do, so this, for instance, would tell me that that machine here, the VMs that I gave you, this lets me know that it's probably on Linode. And yes, that's the case, it's on Linode. Now, if I do that Whois query on that address here, this is going to tell me that we are on Comcast, and yes, indeed, the internet provider where I am right now is Comcast. So we can get a little bit of information, but this is only very indirect information. You know, like I could be like, well, Comcast, okay, I know it's a cable provider in the United States, so this container is probably running on a machine somewhere at some person's home or office, and they're connected with Comcast. Probably, you know, I can do a little bit of detective work like this, but that's pretty much it. Otherwise, there is a relatively good isolation between both. What that means, and now we're going into, that's going to be the last thing I'm going to say on that topic, but there is a pretty interesting thing when you are using package mirrors, just like we did here with Ubuntu. We have different systems here. Sometimes we use a global CDN, and then it's kind of magical because you access, you know, whatever.com. Like for instance, when you access google.com, there's going to be a little bit of magic so that you don't necessarily go to the mothership, like to the main Google servers somewhere in Mountain View or wherever in California. No, when you go to google.com, it's going to somehow get you to the closest Google servers. So even if you are in Asia, in Europe, in Africa, or whatever, it should be relatively fast, hopefully. So you can use something like that, but sometimes you might have seen this when you deploy, for instance, when you deploy on AWS, on EC2, and on Amazon. If you look at the list of package mirrors on a freshly deployed machine, you could see something like this. Let's say us-ist2.mirrors.debian.net or whatever. I'm making this up. It's not going to be exactly this, but the idea is that when you create that virtual machine, because you create the machine in us-ist2, the machine is going to be pre-configured to use a mirror in us-ist2. This is something you can do in the cloud, because in the cloud you could have, for each different location, you know, US West and East and Europe Central and Africa North and South and Asia, etc. You could have your virtual machine images pre-configured, preceded with that mirror information. So if I spin up a VM here, it's going to use the mirrors over there. If I spin up a VM here, it's going to use these other mirrors instead. With containers, it's much harder to do that because the container images will typically be the same everywhere. So long story short, Docker containers don't get a lot of information from the host. Yes, they can still see available resources like memory, CPU, what's the kernel version, what's our public-facing IP address, but they don't get much more information. All right. Oh, and to add a little bit of information to that, what's a mirror in that context? So when you distribute software, it could be Linux packages, or it could be programs to install on Windows, Mac, or whatever, or it could be when you want to download a CD, DVD, or USB stick image. You will often have mirrors. So it's servers with identical content. So for instance, let's say that I'm French and I work in Paris, and I made this amazing program and I let people download it from my servers in France. But folks in China or Japan are going to be very far from not only a network standpoint, but just like geographically speaking. So if they download from my servers in Paris, it's going to be very slow. So instead, I could just like get in touch with someone in Beijing and someone in Tokyo, and they could agree, hey, yeah, we're going to run a mirror. So we're going to set up a server that will have an exact copy of your stuff. So now if somebody in China wants to download your program, instead of downloading it from the French servers, they will download it from the servers in Beijing or whatever. And this has been the case for for any kind of software distribution at scale, not just to have something closer, but also just because when you do something very popular, like a Linux distribution, you will have thousands, if not millions of people or machines downloading it. So it's better to have more servers as well to spread the load across all of them. So mirrors are like the CDNs of the beginning of the internet. It's a little bit like a CDN. So yes, like a little bit like an AWS edge location, except that traditionally they were set up in a kind of manual way. 20 years ago, for instance, I was often setting up lots of Linux machines, and I was using Debian, and I didn't have a very fast internet connection. So what I did is that I had a Debian mirror at home. So I had set up a machine at home that would have a complete copy. So that's why we say a mirror, because it's the same image as the Debian servers. And so now each time I needed to install a Debian machine, I could use my Debian mirror instead of using the original servers. All right. Was there any other question? Is there any harm in setting aliases to Docker Compose up? No, that's totally fine. And yeah, AJ gave a pretty excellent answer about that. Speaking of aliases and things like that, you probably noticed that I was not using aliases here when I'm teaching. That's just because I want you to see the entire commands that I'm running. I want you to see exactly, oh yes, we're doing Docker compose up dash this dash that. I think if I were doing something like DCUB, because imagine I have a custom alias, right? Alias DCUB equal Docker compose up dash build. Whoops. What did I do that wrong, or whoops? What's going on here? No, I was right. I was just in a wrong directory. Sorry. So if I use DCUB instead of Docker compose up dash build, it's easier for me because I have less stuff to type, but it's maybe not easier for you because you might wonder what the heck is DCUB. So that's why I'm not using aliases when I teach, but you can, and maybe even you should, set up aliases when you work for yourself, so to save time when you work. very personal opinion, maybe advice or not. I think when we work by ourselves, you know, when nobody's watching, feel free to use all the aliases, all the shortcuts, all the things you want to work faster. However, personal opinion, but if you write a script or if you are doing pair programming, so somebody is watching what you're doing, in that case, I prefer to write the commands in full, because in a script, it's just easier to read. You know, I can see you know, when you write the script, it's going to take you like 5 more seconds to type docker compose up -- build. But when you read the script, it will be easier to read and it will be easier to catch bugs and mistakes when you have the full command rather than dcub. And then you're like, oh, what's dcub again? Ah, yes, docker compose up -- build. What's if for someone else dcub is docker compose up batch, you know, something like that. So again, if it's just me, yes, I use all the shortcuts and the accelerators and everything I do to be more productive. If I'm pair programming or writing a script, I tend to be very verbose and write everything in long form so that it's easier to read for the other person. All right, awesome. Now I have this Wordsmith app, and I would like to run another version of the Wordsmith app. In fact, let's see, I'm going to do another Docker Compose up here. And when I do that other Docker Compose up, okay, that works fine. Yeah, that's normal. But let's see what happens if I do, yeah, I want to run a second copy, excuse me. So I'm going to do -- project name dev. Whoops, that flag actually goes here, -- project name dev. So that kind of works, but only kind of. We saw that problem yesterday. I can use that flag like -- project name to say start a second instance of that stack, but I have a problem here because port 8888 is already in use. How can we deal with this? Well, one thing I can do is in the compose file here, I can make this a variable, $port. And now I can do port equal, let's say 8889, docker compose, blah, 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 up. So we do this. And now if I do docker compose ps, oh, that's interesting. So we can see the Wordsmith app that I just started, but yesterday I also ran a copy of Docker coins in a project named dev. So now we have a mix of all these containers. So that's a little bit confusing. How can we fix this? There is a special option when you do Docker Compose up, which is -- remove all fans, I think, or fans, which is going to remove the extra containers that do not exist anymore in my compose file. So if I do that, and now I do Docker Compose ps, yep, I only have my 3 Wordsmith containers. So I still have my, my Wordsmith on port 8888, but I also have one on 8889. It's the same app, so we don't really see the difference, which prompts me to thinking, okay, let's go back to a very real, well, almost real and concrete example. Let's say that I'm a web designer or at least integrator, and I want to propose modifications to that app, and then I want to demo that app just like we did yesterday with the Namer app. How can I do that easily with Compose? Well, what I can do is just have multiple directories. I'm going to take my Wordsmith app here, and I'm going to say, okay, let's have Wordsmith original, And then I also want like WordSmith new. All right, let's go to WordSmith original and bring that one up. And now when I do Docker Compose up, it's telling me in the beginning, where was it? Port variable is not set, defaulting to a blank string. Okay, what's going to happen in that case? Let's do a Docker Compose up-d, Docker Compose PS, and it did map port 49169. Okay, but I would like to set like a fixed port number. So what I can do is that I can do just like we did earlier, port equal blah, blah, blah. But I have another technique, which is to use a .env file. So you may or may not have seen and used .env files before, but the idea is that you create a file called .env, and in there you put your other variables like port equal, let's say 9001. Compose is going to automatically read that, that file and use the environment variables in that file. So I can do Docker Compose up-d, and so that used port 9001. Okay, so now I can go to WordSmith new, and in .env I'm going to put port 9002, Docker Compose up-d, and this is going to run a copy of WordSmith on port 9002. Okay, so now I can make some changes in WordSmith new. For instance, I can edit web static style.css. Is there a background somewhere? Yes, that's the background color, and we're going to put, I don't know, background blue. It's probably going to be awful, but let's see. Now I do a Docker Compose up-d -build. All right. So now if I compare port 9001 and port 9002, yep, that's the original background, and that's the blue background, which is bluer. Okay, so that lets me have two copies of the application running side by side. And if I need to do some, let's say, local adjustments, like local changes, I can do that in that .env file. And so typically in that .env file, you're going to find, you know, like it could be port numbers like this, but it could also be passwords and API tokens, and are we in debug or production mode, etc., etc. So now I want to continue working on that new version, but I don't want to rebuild each time. Remember yesterday for the Namer app we used volumes, so I would like to use a volume as well here. How am I going to do that? So this is for web. So the interesting part is static. Okay, so I want to create a volume for that static directory. And where does it go in that Docker file? Not clear. Let's go and have a look in that container. So, new situation, I want to enter a container and have a look at what's going on in there. So I can use Docker exec. I think I did Docker exec yesterday, maybe even Tuesday. I can also use Docker Compose exec. You can do Docker Compose exec web, and then I need to give the program that I want to run in there. So if I want a shell, I can use bash. There we go. Okay, so little interesting fact, in the Golang image that we use for this container, the default directory is /go. So when I did my copy ... everything was copied in /go. So you can see my Docker file, my dispatcher.go, and my static directory. Okay, so it means that I want to map the directory it's going to be web/static. I want to map that to /go/static in the container. All right, let's do that in the Docker Compose file. I go to web and I add volumes ./web/static : /go/static. All right, now I do Docker Compose up. Okay. And now I'm going to make changes in there. So cd web static, edit style.css. Instead of blue, we're going to put red, and so that's going to be absolutely horrible. Yep. But at least we got the change in real time, like immediately. You see, it's exactly what we did yesterday, but now I'm integrating that in my Compose workflow. What else can we do? Let's talk about a slightly different scenario. Let's imagine that this application is, instead of being a little demo like this, imagine that this is an accounting application, and I sell that to small businesses, so like a SaaS, software as a service. And I want to have one copy, like one instance of that app for each of my customers. So I have maybe 5, 10, 20, 100 customers, and for each customer I want a complete stack, and I want that to require as little work as possible on my end. Well, what I can do, here I could create a directory called, let's say, customers. And here I'm going to have my different customers. So maybe there is a Foo Corp and also Quack LLC and LOSAS. Let's say these are just like 3 of my customers. And now in each of these directories, I'm going to create a .env file. So I'm going to put .env port equal 10,001. Then in Quack LLC, we're going to put port equal 10,002. And the last one, like Hello SAS, I'm going to put port 10,003. Now the trick, and that's the whole kind of beauty of Compose in that case, is that it will be able to use the .env file in this directory, but it will still use the Compose file in the upper directory. Oh, and there is one last thing that we need to do. We need to change the project name for each of these, and I completely forgot to do that. So basically, you do that in the environment by putting project name equal, etc. All right, let's do a little bit of shell scripting here for C in all my customers here. Do echo project name equal $C to $C/.env. What did I just do? I just added project name equal name of the customer in each of these .env files. So now the result is that I can go to Foo Corp and do Docker Compose up-d. No, looks like that didn't work as I expected. Is it Compose project name? Yes, that's compose project name, not just project name. My bad. Okay. So let me fix that. So I can remove the .env file at the root. Okay, so here it's compose project name, and that one is also compose project name. Okay, so now I can go to each of them and do docker compose up-d. Okay. Yep. And finally to, what was the last one? Quack LLC. And now I have multiple copy of the application on 10,001, 10,002, 10,003. And of course, these copies are all identical. So if we wanted to go, the next step would be to use something in the environment and inject it in the web page so that it would be a little bit different, so that we could see, oh yes, it's the application has been customized. But what I'm trying to illustrate here, and I do apologize for the little mistakes on my end when putting that demo together, but how do I show hidden files? Is the hidden, where is it? -A, okay. No, that's not exactly what I wanted, but almost. That's the interesting part. So what I'm trying to show here is that I can use a single directory with my code base. I have a single compose file. I have only one copy of my Docker file. So I have all my things here. And now if I want to start 3 copies or 10 copies or 50 copies of that application, all I need to do is to write the little .env file that will have the specific parameters for that particular copy of the application. You may or may not need that in practice, you know, like, but if you typically, if you work in, let's say, a small or medium-sized web agency, and you have hundreds, if not thousands, of applications and websites for small or medium-sized customers, so that kind of pattern can be extremely convenient, extremely powerful, because with very little work, now you can instantiate this application n times. All you have to do is create like this environment file, set a few values, and boom, you get a complete copy of the application. All right. So that's what I wanted to show you with Compose. Let's see. Let me check here if are there some interesting options that I did not mention. One thing that's worth mentioning is that if you're using a database, when you how can I explain this? When you use a database like Postgres, Redis, Elasticsearch, etc., the container is going to store the data in a volume, and that volume will persist across restarts and recreations of that container. I'm not going to do the full demo here, just give you the general idea. Okay, let's say I'm using Postgres version 12, and now there is Postgres version 13. So I update my compose file to put Postgres version 13, or maybe I update my Docker file to put from Postgres 13 instead of from Postgres 12. So normally, when you recreate a container, all the data that was in that container is lost. Remember, on the first day when I was running Ubuntu, if I install something in my container and then I Docker run Ubuntu, whatever I installed is gone. Or rather, it's not gone, but I created a new separate container. So with stateful applications like databases, Compose has a kind of special trick, like a special technique, where when there is some data stored in a container and you, for instance, update the image. So let's say this is my container and this is the data in the container. So it's detecting, oh, you want to recreate a new container. Okay, so instead of creating a new container without the data, it's going to create the new container and then it's going to attach the data to the new container. So when you update either your container image or some parameter in the Compose file, etc., Compose is going to kind of carry along the data to the other container. So that's pretty useful, and generally it's what you want. Generally you want to keep your data, but once in a while you're going to have the opposite issue where you're like, no, I want to wipe out the data and restart from scratch. How do I do that? And the easiest way is to do a Docker Compose down and then a Docker Compose up, because this is going to recreate completely new containers and they're going to have a completely new volume. All right. Now, one last thing before I turn the page on Compose. I was just giving you that example, like, oh, what if I'm a small agency and I have a few hundreds of customers and applications, and would we actually use Docker and Compose for production scenarios like this? And the answer is, it depends. We could have a very long debate about, oh, should we use Docker like this for production, or should we use Kubernetes? If I'm using Kubernetes, can I still use Compose, for instance? The full answer is a little bit complex, but generally what we see is that people will use Docker and Compose when doing local development because it's relatively simple. Remember the demo I was doing yesterday? You git clone a repo, Docker Compose up, wait a couple of minutes, the app is up and running. It's really hard to do something simpler than that, so that's great. If you move to the Kubernetes world, it's going to be way more complicated to get started. So very often, what many folks do is that they use Compose locally for development, and then when you go to production, you go to Kubernetes. I say generally because it's not an absolute rule. It depends on lots of factors and parameters. My personal flow chart, the way I decide my production, is it going to be Compose or Docker or Kubernetes or whatever? It's very simple. There is one question: can my application fit on a single server? How many servers do I need for this application? If my application is small, simple, not a lot of load, not a lot of users, everything can work on a small machine, then I'm going to use Docker and Compose. However, if I need multiple machines, maybe because I have a lot of load on the system or I have like millions of users or whatever, if I need multiple machines, then I will probably use Kubernetes. Now, to give you a concrete example, the streaming platform that we use for this course is running on Docker and Compose, and I can even show you what this looks like. There we go. So the main, what we call the ingest server, so the server that receives my video stream, is located in the US, and there is a Compose file. Now, to be fair, it's a pretty big Compose file. As you can see, it's like, wow, 200 or 250 lines. So yeah, pretty chunky Compose file. But it's running a bunch of containers. Now, if I do Docker Compose PS, You can see that we have, so this is the authentication system, cAdvisor, it's for metrics, ingest, that's the thing that receives my video stream, Mattermost, that's the chat platform, Nginx RTMP, that's the thing that gets the video stream and transforms it in a browser compatible format. That's also for metrics, that's the database for the chat platform, etc., etc. But all that thanks to Compose. There is a .env file. I'm not going to show you the .env file because there is some like passwords and confidential information in there. I'm just going to show you that the .env files is relatively big, like 70 lines, because in there we have tons of information, like when you go to the when you go to that page, all the links here are generated from the .env file. The address of the materials, the address of the chat room, the link to the Google spreadsheet with the virtual machines, all that is in that .env file, which means that in concrete terms, when I'm about to teach a course and I need to set up that platform, it takes me, I don't know, maybe 15 minutes to get everything up and running. And in that 15 minutes, more than half of that is waiting for the virtual machine to be provisioned by the cloud provider. So that's to give you a little example of, yes, we can do production with Compose in some specific scenarios. This is a scenario where here, honestly, there would be no interest for me to use an orchestration platform, something like Kubernetes, because everything is on a single machine. Everything fits on a single machine. So there would be no upside in using something like Swarm, Kubernetes, Nomad, Mesos, etc. All right. So that's everything I wanted to tell you about Compose. Do you have any questions on Compose before we move on to the next topic?